Hey everybody, this is Larry. This is Miko with Q3 of the weekly contest 329. Apply bitwise operations to make strings equal. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So the first thing that I did is, when I see a problem like this, and spoiler alert I suppose, is kind of write out the truth table. And you could actually, if you watch me solve it live in the contest, you actually see me do this, right? So something like this, and then I just write it out, and this goes to 0 0 1 0 is 1 1, yeah, and then 0 1 is also 1 1, and 1 1 is equal to 1 0, right? So what does this mean to me? This means to me that well, if we have just 1 1, then you can flip any number, you can flip any 0 to 1s, right? And if you have 2 1s, you can flip any other number of bits to 0. So there are only there's only one impossible case, or depending how you want to say it. But so if S contains a 1, then it always will have at least 1 1. And that 1 can be anywhere, because you can kind of think about them as shifting it over by flipping one bit on and then flipping the original bit off or something like this. So you can have any number of 1s, and it could be all 1s, but you have at least 1 1, right? So, and you can make any other string. So that's basically the idea behind that, because that means that if S has all zeros, then target has to be all zeros, and otherwise, yeah. Otherwise, then everything is possible, unless, yeah. And that's basically the way that I put it here. I think I wrote it this way, which is that the number of zeros, so this is basically, is it all 0? If this is all 0, and if they're both all zeros or they're both not all zeros, then you can make them equal. Otherwise, if one of them is all zeros and the other is not, then you cannot. So that's basically it. This is going to be linear time, because of the counting takes time. You have to look for every strings, and constant space, because that's just a count. Cool. That's all I have for this one. Let me know what you think. And yeah, this one can be very tricky. I definitely took longer time. I got the logic kind of okay time, but I took a lot of time just proving to myself. So even though I said everything really quickly, definitely think about it and think about the logical observations that makes from it. This is not easy observation to make, but you have to figure out all the implications, and maybe even play with yourself all the ways that are possible and not. And it took me a couple of minutes, if you watch the tapes, that I'm just like, oh, is this right? Is this right? Is it actually right? And so forth, right? So yeah, that's all I have for this one, and you could watch me solve it live in the contest now. Okay, well, I just kind of missed about the max min. That's a very silly 2 columns, maybe. Okay, apply bitwise operation, make strings equal. What are the iterations? IJ, replace I with I or J, and J with X or IJ. What does this mean? What does this mean? This means that, I mean, we can start with the table, right? Then this is going to be 0 0. XOR is exclusive OR, right? So 1 no, this is going to be 1 and then 1. Still 1 and then 1, right? Yeah, okay. And 1 1 is going to be 1 and then 0. Is that right? Did I mix that up? Or and then XOR. That makes sense, but what does that mean? Okay, so we have this, and we're trying to make them equal. So basically, we can. I'm trying to figure out in the variant here. Basically, we can flip ones on, and then. So is everything. What is not possible? It seems like everything is possible. We just could add Okay, so 0 zeros doesn't do anything, but as long as we have a 1 0, we can flip on a 1, and then we can also flip on 1. But if we have 1 1, then we can flip on 1 0. Okay, I think that's fine. Maybe. Let's see. 1 0. So 1 1, we can flip one of them off. Okay, and then 1 0, we can flip that on. Okay, so that means that we have at least 1 1, then we can 1 0. I feel like I have a thing, but I'm not. Okay. It's kind of an awkward one. How do I want to think about it? Okay, so 1 is equal to s dot count of 1. I mean, maybe, right? I feel like a lot of these cases are possible as long as we have like I almost want to YOLO a little bit. Like if target that count of 1 is equal to 0 and s dot count of 1 is equal to 0, then we return true. Otherwise, if I almost want to write something like this, but I can't really. I'm trying to think of other cases. Is that sufficient, or am I missing a case? No, n is 2. I was thinking that n is equal to 1, maybe a weird case, but can I prove this? They're all zeros. They're all zeros. Oh, this is all zeros. Okay, but then you can make every other number just by like shift, right? So maybe I'm gonna YOLO. Spent so long proving on that one, to be honest. Like I knew that one a little. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this video, and the contest and everything. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.